Hello everyone, my name is Joe Malone. I'm with my partner Jacob Haft. Today we're going to be going over the overview of an SLA suspension on a 1984 Oldsmobile Custom Cruiser and a 1971 Chevy Cheyenne 20.
Alright, we have the Oldsmobile up in the air. We're going to take a look at the components that encompass a SLA suspension. Starting over here on the passenger side, we have an outer tie rod end. And then this is what you would use to adjust the toe on the passenger side. And then you have an inner tie rod end. Now this tie rod assembly connects to a center link, which also connects to your idler arm and your pitman arm, and then also your tie rod assembly on the driver's side, which again has an inner and an outer. So when you're adjusting toe on these vehicles, what you do is you loosen these clamps and turn this knuckle in or out, and that will lengthen or shorten this tie rod assembly, changing the toe on that side of the vehicle. Now the reason it's called an SLA suspension is because it's short and long arm. The lower control arm is your long arm. And it might be hard to see, but above that is your upper control arm. And you can see how much shorter it is than the bottom, hence the name. So when you adjust toe on a SLA suspension vehicle, there's a few things you want to take into account when you're putting the vehicle back together. The first of which is that these clamps are not directly over the slit that you use for adjustment. The reason for this is because if these bolts were directly over this, the clamping force can actually egg or make this channel here oblong, and then it won't be able to adjust properly on the threads the next time someone has to align it. The next thing you want to check for is that there's movement in this bar after you adjust it. And the reason for that is, if there was no movement present, these tie rods would be bound, twisted side to side, and then it just causes excessive wear and excessive resistance when turning or going over bumps.
So on these components on SLA suspension, there is a common component called a ball joint. A ball joint is used as kind of a ball and socket and moves in and out like this. It does not move as easily on a regular vehicle. This is a worn one. But that uses an axis point for this long arm and this short arm to move. Right here you can see the upper control arm ball joint, and down here you can see the lower control arm ball joint. On tie rod ends, they also have a similar system. It's not called a ball joint, but it also works as a ball and socket movement. So now when it comes to the sprung and unsprung weight of the vehicle, everything below the lower control arm and the spring, so the wheel assembly and the brake assembly, is all unsprung weight. Everything above the spring, meaning the frame and all of this, is all considered sprung weight.
So now we're going to look at the stabilizer bar portion of the suspension. So the stabilizer bar runs from lower control arm to lower control arm, but also attaches to the frame with bushings. Here you can see an example of a bushing that is fine. There are no cracks in it, the rubber is not excessively worn, and it's tight up along in there. Now on this side of the vehicle, this is a bushing that would be bad. You can see how the rubber's falling out, falling apart. I can almost just tear it right off. This would cause excessive vibration and bumps as that car goes up and down and that sway bar flexes and unflexes. Now, a quick way to measure the diameter of your sway bar, since they are round, is to take a wrench and an open end wrench and put it up there. If it fits snugly over the sway bar, the size of the wrench is the diameter of the sway bar. So this one would be 1 5/16 inches, which is a pretty heavy sway bar. Here we have a simplified view of an SLA suspension. The main purpose of the SLA suspension is to minimize tire scrubbing during jounce and rebound. Tire scrubbing is a side-to-side motion that the tire does at the contact surface of the road, side to side. So when the vehicle will encounter a bump, we'll see the suspension move up and down. The center of the line of the tire does not stray very far from where it was contacting the road previously, before the bump.
Alright, so now we are on this 1971 Chevy C20, and we're going to go over the same kind of suspension, SLA, short long arm suspension, but this is a much beefier and a little bit older suspension due to it being a 3/4 ton truck. Alright, so comparing this to the olds, we can see a lot of difference based on just basically size and grade of steel and such. So if you look at these ball joints to start off, these are probably almost double the size of Jacob's, or the Oldsmobile. If you look at the spring, a larger diameter coil right here, and then the control arm itself is, I would say, probably double as large. This is just meant for, it's a heavier vehicle, much heavier truck, and it's meant to tow a lot more. So the load on this is a lot different than what you are expecting to be in an Oldsmobile when you are expecting to tow something. So to point out another difference of identifying the suspension, to adjust camber on this, it is different than the Oldsmobile. So these shims placed in the back here on the upper control arm are used to bring the tire in and out to adjust the camber. On this truck, it is on the outside of the frame, but on an Oldsmobile or the car platforms, it would be on the inside of the frame.